Okay, so how's everybody doing? Good. How was last class? Good. You understood everything, so I don't have to go over anything. That's great. One thing before we start today that I'll point out is you know this hopefully already, but the first assignment is due in a few days, right? It's due on Monday morning by 8 a.m., which really means that you should have it done by Sunday night. So there's a few people still having issues with that. Please take advantage of the TA hours that are still available to you. Tomorrow, for instance, there's hours from 10 o'clock to 12 o'clock and 1 o'clock till 3 o'clock. So if you're really stuck, go see a TA. And some of you, I know there's a handful of people who have come to see me and said, oh, I spent a lot of time on this, many hours, and I still can't run Python, or I can't install Python, or something. If you find yourself in that, seriously that stuck, then the thing to do is go see someone. Ask someone on the forums for help. Go see a TA if there's still TA hours available. Something like that. Don't just sit there and fight it all by yourself, because at that stage you're not really learning what you're supposed to be learning about the course. You're just struggling with some system problem that is not really relevant to the course. It's just getting in your way. Having someone else who knows this stuff show you how to fix it is not going to hurt you. You're not going to miss out on something by doing that. So, well, so many of you are doing this already, but I encourage you to use the forums. In particular, since assignments are due Monday mornings, that's basically where you're going to be able to get help over the weekends. The TAs monitor them, but it is the weekend, so they won't be able to do too much. But the students, of course, there are some students in this class who have a lot of experience, who are quite good programmers already. They offer help on these things as well. So I encourage you to do that. Before I start, does anybody have any questions for me? Yeah.
Where were you on last week? Because you had a baby.
Yes, on Tuesday. Tuesday, my wife had a baby. Yeah. I'll pass that on to her. I didn't have much to do with it. Any other questions? Yeah.
What's his name?
Sawyer. So. Any other questions? Yeah. Can we what? It's probably not going to make much difference for the first assignment, but I would advise against it in general, because you may be using a feature that's only present in Python 3, or you may be relying on a default of Python 3, like the right way to do division, that's not present that's not the default in Python 2.7. And so TAs, if they test your code, will be testing it on 2.7. So there's some danger you could lose marks because of that. So I advise against it. Yep. Should we? Well, it shouldn't round too much, in the sense that, I mean, there's a conversion factor, and I mean, you can grab that off Wikipedia up to like 10 digits if you want. So, I mean, if you multiply by that conversion factor, then there'll be some tiny rounding in the 10th digit, but otherwise it shouldn't be an issue. Yeah. Sometimes you may have a little more precision or a little less precision, but it's not that's not an issue. I mean, if you're off in the third digit after the decimal place, then it's probably fine. Okay. Yep.
For question 11, you said that we have full marks on the question. We have to not use loops and if statements.
Yep.
Does the round function use an if statement? Like
The round function you can use. So all the standard things, round, min, max, the conversion to int, all those things you can use.
Okay.
Yeah. I just don't want to see an explicit if statement or a while loop or anything like that. No for loops either. No, there's no branching in your own code, maybe inside a function that you call. Yeah. Did I what? Yes. Oh, mic. I don't know where the mic is. It seems to have been taken from this room, or they're hiding it in a place. Ah, there it is. It's hiding in this drawer here. Good. Be careful. This one has no clip. How's that? Is that better? Good. Other questions? Good. So just a couple of things I'd like to check. Did you guys see, I looked at the sample code. Did you see any of the built-in string functions? So things like find, upper, lower, endswith, title, center, those things? No. Okay. So I'll just quickly show you those. And well, I think these we can do even without a file. We'll just do them from within the interpreter. So you know there's many ways to define strings. How's the font size? Good. Okay, good. So you know there's many ways to define strings. And I wish I had a higher chair. This is exactly the awkward height. Let's try standing up at the higher desk. So there's a few ways to define strings. One version is with simple double quotes, and you can say, this is my string. So this defines a string, a variable s, which is assigned a string. This is my string. And these strings have a few different methods you can apply to them. So one of those methods is the find method. So I can say s.find my, and the answer is 8. So do you know why the answer is 8? Yeah. Yeah, so the string my starts at position 8 inside the string s. It's this position right here. And strings are indexed starting at index 0. So this is, the t is at position 0, position 1, 2, 3, 4, 5, 6, 7, and indeed there's the m in my starting at position 8. So you can find things inside of strings using s.find. If you search for something that's not there, then you get back the answer -1. So that answer doesn't make sense as an index into a string, so it's telling you that it's not found inside the string. Okay. Something else you can do is replace parts of a string. So I could replace my with your. And then I get back a new string that replaces the word my with the word your. So this is your string. Now, replace is maybe a little bit of a misnomer because it doesn't really change the string s. If I look at s again, it's still the same string. It's still my string. It's unchanged. This replace function or method just gives you back a new string which has the replacement done inside of it. And replace doesn't care about whether it's a word or anything else. It'll replace basically any substring, any bunch of characters. So for example, I can replace my string with your dog, and this turns into this is your dog. Okay? So you can replace things in strings. You can ask to convert a string to uppercase. If you want to shout it, you can shout, "This is my string." Or you can convert strings to lowercase. If you want to look cool, you can lowercase it and say, "This is my string." You can ask questions about strings. So you can say, does this string end with a particular string? For example, does it end with ing? Is that true or false? Oops. Ends with. It's false. Why is it false? Yep. Because it actually ends with ing exclamation mark. And of course, there's ends with, so there's also starts with. Does it start with this? True or false? False. It starts with this with a capital T, not with a lowercase t. So uppercase, lowercase, all of it matters. If you don't want that to matter, then the usual trick is you convert your strings, all your strings to lowercase, and then you only, and all the things you're searching for to lowercase, then all of that goes away. There's some funny capitalization things. One of them is string.title. So there's uppercase, lowercase, and title case. Oh, just s.title. This tries to do something and pretend that your string is the title of a book or something, and uppercase is the first character of each word. Sometimes it's useful. And then there's a funny one, s.center, which takes an integer argument and gives you back a string which is as long as that argument and puts your string in the center. It puts spaces on either side. So this is a way to do some really cheap text formatting, not to really turn your console applications to give them a little bit of bling by centering things. Okay, so those are some of the built-in string functions. But like most things in this course, really the way you learn them and the way you learn what's available is not by watching me do stuff, but by using the documentation. So if you just Google Python string, you'll find all of these things, formatting functions. I don't know if you'll find the stuff we were just looking at in here. Yeah. And just, yeah, so A to F, A to I, A to L, capitalize, expand tabs, find. Find is a little bit ambiguous because the string you're searching for could occur in more than one location. You can either ask for the first occurrence using find or the last occurrence using rfind. Bunch of these variants of find. Count the number of times a substring occurs. A useful one, which we'll look at in a few seconds, is split, and then a bunch more. So go ahead and you know, if you need to do something with a string, and I didn't show you how, which is more likely than not, then please do look at the documentation before rolling your own. Okay. So that's just to finish up the second class. Now, the main thing that I want to talk about today is what in other languages are typically called arrays, or sometimes called vectors. In Python, we call them lists. But unfortunately, I didn't grow up programming in Python. So these things, to me, have been called arrays. I've been calling them arrays a lot longer than I've been calling them lists. So in this course, if you hear me say array, I really mean a Python list. There are no real arrays in Python, so there's nothing to get confused with. If I say an array, I mean a Python list. And so sometimes I'll say list, sometimes I'll say array. It means the same thing to me in Python. Okay? So what are arrays good for? Well, we know that computers are really good at working with lots and lots of data. We even have a program here that's sole purpose is to study big data. And so the question is, well, how do you get big data inside a computer program? Well, you end up storing it inside a data structure, and the most basic, most fundamental such data structure is an array. Now, an array is just a sequence of values stored one after the other. There's lots of ways to define them. In Python, the simplest, the first thing you see is the array literal. So for example, let's define an array called A, and it can contain maybe the letters A, or the strings A, B, and C. And now, so that you use square braces to say that what you're putting in here is an array, and you separate the elements with a comma. Lots of things go for arrays in Python that you're not used to if you work in other languages. For example, this array contains strings, but if I like, I can put some integers in there as well as a floating point number. And Python is perfectly happy to do that for you. So there's no problem there. It's all good. Okay. So that's the array literals. What else can you do with arrays? Well, you can index them. So the elements in an array are numbered, starting at position 0. And so A is at position 0, B is at position 1, C is at position 2, 2 is at position 3, and this abbreviated version of pi is at position 4. And so if you've programmed in other languages before, you've seen this notation. A at 0, that's A. A at 1, that's B. A at 2 is C. And 3, 4. So they're all in the places we'd like them to be. Be careful if you're new to programming. Starting at counting at 0 is sometimes unnatural for people, but once you've studied computer science for a while, it's really the most natural way to count. In addition to looking at the values in an array, And when I say looking at them, you can really do anything you want with them. For example, if I take a at 4, which is this version of pi, and I add 2, then I get that value plus 2. So you can just use these inside of other expressions to do whatever you want to do. You can also change the values in an array. So I could say, for example, a at 2 is equal to c. And that changed this value here, which was a at position 2. It just reassigned it to give it the value c. So, so arrays, you can really change them. You can change the stuff that's inside them. So there's something you can do. Here's something you probably haven't seen before, even if you have programmed in other languages. I could say a at 2 colon. So this is a notation. It's called the slice notation that says, give me a slice of the array A starting at position 2 and going right to the end of the array. And so I get the tail of the array that starts at position 2. I can also do a slice that ends just before position 2. So if I put the colon before, that says give me everything up to but not including position 2. And I can use a couple of digits in here. For example, I can ask for everything starting from 1 up to position, but not including position 3. So what's that going to give me? So what values of the array will show up? What's that? B to 2. So the elements at positions 1 and positions 2, but not position 3. So that's B and C in the array, right? That's A at 1 and A at 2, but we don't get A at 3. So these slices are what are called open intervals or half open intervals. The right endpoint is not included, but the left endpoint is. So when I say 1 to 3, I get 1 and 2. If I say 1 to 4, I'll get 1, 2, and 3. All right. Something else you can do with slices is you can actually use 2 colons. So here's one. I'll skip the first 2 parts and just give the last one. Let's look at A again. And let's say skip the first 2 parts, and I'll just give one last argument, 2. So this gives me A, C, and 3.14159. See why?
Only one divisible by 2.
It gives you only the indices that are divisible by 2. So index 0, index 2, and index 4. That's where the A, the C, and the 3.14159 are sitting. But more generally, it's taking the range that I specified. And in this case, I didn't specify either the start or the end, so it's just taking the whole array. And it starts at the start and starts counting by 2s and taking the first, the 0th element, and then the 2th element, and then the 4th element, and so on. And so I can do this with, subslices. Let's say I wanted to start at 1 instead. Then I'll get just B and 2 before running off the end of the array. And there's nothing that says I have to, this skip has to be 2. I could skip 3 things at a time. Then I'll get B and 3.1415. Right? So I start at position 1. That's B. and then jump ahead 1, 2, 3, and I get this version of pi. Here's something else maybe you haven't seen. A at -1. What do you think that does? So Python allows you to use negative indexes in these arrays or lists. And when you specify a negative index, that means you're indexing from the back of the array and working backwards. So we start at the last element in the array is at position -1. At position -2 is the second last element. At position -3 is the third last element, and so on. Now, what do you think this does? So this is a slice that says beginning to end with the skip of 1. Want to tell me what that'll give you? Yeah. Gives you the whole array. What do you think this does? So this says, give me the whole array. There's no beginning or end specified, but the skip is -1. So it actually counts backwards through the array. So this reverses the array. Okay. And often in Python code, you'll see something like this, which is a short version of the whole array. So give me the whole array. So you might ask, why do you want to do this? Well, we'll see very shortly that arrays are a little bit different than some of the other data we have, because arrays, you can change things. So we saw you can change the values inside an array. And that means that sometimes we would actually like copies of arrays. Because we're about to change it, we might want to change the copy, or we might want to keep the copy before changing it. And so this A at whatever looks like it's giving you the same array, but it's actually giving you a copy of it. So if I were to change that, nothing, it wouldn't affect the original array. But we'll get more into detail about that soon. Another common way to make arrays is out of strings. So there's a string. Strings have a method called split. So the split method in strings, if you don't give it any arguments, it will split at white space. So anywhere it sees a space character in the string, it'll split it. So it's sort of like splitting it up into words. And so what s.split gives me, it takes a string and gives me back an array of strings. Right. So if I assign this to A, then A is actually an array now of strings. A at 0 is the string this. A at 1 is the string, is, and so on. Okay. So we can get an array by splitting a string. That's a handy thing to do very often. If you ever look at, things that your spreadsheet can open, one file type that you sometimes see is these CSV files. Those things are just a bunch of lines separated by commas. A typical line might look something like this. It might be so you might read a line like this from a file, and usually what happens then immediately is you call split, but you specify an argument and say, I want to split this at commas, and then that gives you the data split out into an array like this. Much more useful, manageable way of doing this. Okay. So far, so good. So if you can split things, that usually means you can join them as well. And so let's say B is that. So now I have this array B with these strings in it. And there's a way of joining an array of strings up to make one string. And it's a little bit, the notation is a little bit funny. You specify a string. So for example, in this case, maybe I'll specify, well, the string that has just one character. It's the tab character. And you take the join method, that string's join function, and you pass it an array, the array that contains all the strings you want to stick together. And what comes back is a string which has, it's the concatenation of all of these things that were in the array B, and in between them it inserts that string that you specified. So here I did it with tabs. I could have also done it with maybe 2 spaces. Then you get something like that. I could have done it with, you know, whatever you want. So you get this nice thing. And this is kind of a handy one because writing a loop to do this is a little bit annoying. The reason is that last element of the array is a little bit different because it doesn't have the separator after it. So join is a handy method that puts the separators in between, in the middle of these things, and then the last one doesn't get the separator after it. So you can split strings to get an array. If you have an array of strings, you can join it to get back a string. Something else I should point out, let's see, we still have the string S, is strings, well, they're sequences of characters, right? That's what we learned last class. And arrays are sequences of things. So maybe strings and arrays have a lot in common. For example, strings you can index. S, that string S at position 5 is just that one character there. And well, if strings support indexing, maybe they also support slicing. And indeed, they do. So you can take a slice of a string. You get a substring this way. This starts as the substring that starts at position 5 and continues, but does not but does not include position 12. And of course, all the tricks you can do with arrays, you can do with strings, including reversing them with this : :1, or if you like, taking every second letter of the string, whatever you want, you name it. All of the things you can do with arrays that way, you can do with strings. There's one thing you can't do with strings, though, is to change them. Try that, you'll get an error. It'll tell you that string objects do not support item assignment. So I tried to assign position 5 in that string to the character X, and it just tells me you can't do that. That's not allowed. You can't change strings. You can't modify strings, but you can modify arrays. Okay. So, any questions so far? Yep.
So the strings in Python, they're dynamic or they're not static?
No, strings in Python are completely static. They're what's called immutable, meaning you can't change them. Once you make a string, that's it. It's made. You can't change it. You can ask for another string that's made from that string, but you can't change the original string. So, arrays you can change, right? So Arrays, I could say, for example, at position 1 equals isn't. And so there I've changed is to isn't in that, that array. Yep. Okay, so split, let's make sure that I get this right. Okay, so s.split, and so it takes an argument which, if you give it, the easiest thing is when you just give it a single character. Then it's going to split every time it sees that character. So it's going to eat that character, and you know, that's going to create a new array entry. So here there's only one m in the string s. So if I split it, oh no, that's not true. There's two m's in the string s. So if I split it, that's where the split happens, right? Here's the first m. It gets eaten during the split operation, and then here's the second m. So we get 3. There's 2 occurrences, which means we'll get the stuff that comes before the first one, the stuff between those 2, and then the stuff that comes after the last one. Now let's see if I remember, if you put in more than one character as an argument to split, yeah, then it just looks for that substring in the string and splits at that. So if I split that string at my, then I only get 2 parts because my only occurs once in the string. So put any string you want in there, it'll just go looking for that thing, and every time it sees it, it'll break the string there and add a new element to the output array. Yeah? If you have multiple occurrences of what? No, let's find out. So you do get a split with empty strings in between. So makes sense, right? Between the first my and the second my, there's an empty string. There's a string with nothing in it in between those. So the length of the array that you get will be 1 more than the number of occurrences of the separator all the time, even if the separators are side by side. Yep. They have nothing in them. They're just empty. They're just a string with nothing in it. And of course, you know that split and join are reverse in this way. If I split on my, well, let's call this thing Q. So there's Q, and if I say my.join Q, I get back exactly the same string again. So all of those gaps in the array turn into the string my again. That one is really the inverse of the other. Any other questions? No? Good. And of course, so we've still got this guy. One thing you can ask about both strings and arrays is their length. And that's just the built-in len method, short for length. Tells you the length of the array. Now, the length of an array is just the number of elements in that array. It doesn't matter what those elements are. That has no effect on the length. It's just the number of them. So, for example, this array here has 10 strings in it. It doesn't matter that those strings are long or short or even empty. That wouldn't matter. That's the length of this array. the string s, the length of it is the number of characters in it. And, well, one thing we can figure out now is if A has length 10, then if I want to look at an element in A, what are the valid indices that I could look at? Yeah. 0 through 9, right? So I can look at A at 0, 1, 2, even all the way up to 9. But if I try and look at position 10, I'll get an index error. And it's an informative one. The list index is out of range. Now, of course, that's not strictly true because I can also look at -1, but that's a different story. What's the smallest negative index I can look at? Is it -9? No, I can even go to -10 because the negative indices start at -1, so I can go -1, -2, -3, all the way up to -10. If I try -11, again, I'll get an index error because I'm trying to look before the first element of this array. Okay. So these index errors are pretty common, easy to find and chase out of your program. Okay, so we can make arrays either by splitting a string or by specifying the array, one element at a time between these square braces. There's another very handy way to make arrays in Python, and that's through the range function. So there's this built-in method called range, which makes arrays for you. And what it puts in those arrays are integers. So the most basic version of range takes one argument, and it's an integer, n, let's call it, and it gives you an array containing 0, 1, 2, 3, up to n minus 1. And of course, then, if I look at one of those things, what's the value at position 4 in that array? Quick. Wrong. 4. The value is just equal to the index, right? The values start at 0 and go up to the length of the array minus 1. So this just gives you an array whose indices are equal to its values. Range has multi-argument variants. So for example, there's a 2-argument version which behaves a lot like slicing. If I call range 10, 20, I get an array that starts at 10 and goes up to but does not include 20. So 10 through 19. And there's, also a 3rd argument. I can do 10 to 20 by 2s, and then I'll get only the even numbers between 10 but not including 20. And negative numbers work as well. 20 down to 10 by minus 1s, starts at 20 and counts down to 10, but does not include it. Okay. I always tend to forget exactly how that works when you use a negative value, whether it includes the first argument or not. For the range function, you have to put them in this. If you're using a negative value, the large one has to go first, and then the smaller one second, and it includes the first argument, but not the second one. I usually have to write those pieces of code once or twice before I remember exactly the behavior. The nice thing is, with Python, you just fire up the interpreter, try it out, and you know what it does. You don't even have to go looking for any documentation. So there's those 3 versions of the range function. Nice thing about those is you can get a lot of data really quickly, right? So range 100,000. That gives me an array whose length is 100,000. Let's look at it. Not terribly useful to look at those things. Now, one of the things we can do with arrays is to count. Or not to count, but to iterate over them. So let's try just something a bit silly. So let's try writing a function. We'll define a function called count. And we'll write the documentation first. Counts from 1 to n, printing the counter as it goes. So we want to count from 1 to n and print this counter as we go. So any idea how to do that? So we want to do a for loop, but a for loop over what? Okay, from 1 to n plus 1. So we want to say for c in range, and you say 1 to n plus 1. So range 1 to n plus 1, what is that? It's an array. And what's in that array? Numbers. Which numbers? Yep.
Every number from 1 until the last number in the array.
Every number starting at 1, and what's the last number? N, because range doesn't include that last number, right? So this will have all the integers 1, 2, 3, 4, 5, up to n in it. And this for loop says, what I want you to do is take this variable c and assign it those numbers one at a time. So first time you go through this loop, c will be equal to 1. The second time it will be equal to 2. The third time it will be equal to 3, and so on all the way up to n. And let's just print c. Let's understand if that works the way we think it does. Python. So let's count to 10. Indeed. So this goes through this array, counting up to 10. So let's take this apart maybe a little slowly. Let's make another array, A, B, C, D. So I can do the same thing and say, well, let's say for x in A, print x. So what will be the output of that? So it'll print the elements of A one at a time. Each print statement puts an element on a new line, and it's going to assign. So basically, it's going through the array saying, first thing, x equals A, then print x. Now x equals B, then print x. Now x equals C, then print x. Now x equals D, then print x. Indeed, that's what we get, A, B, C, D. Okay. Yep.
So does that mean that like your first variable is always going to be? I'm just wondering if you can elaborate a little more on how the x variable is assigned.
Yeah. So if you've programmed in other languages, this isn't usually the way for loops work. In other languages, this is often called a for each loop. But basically, the notation is for some variable name in some array, and then colon. Okay, so variable name is just the name of the variable you want to use. I've used x in this example, and I used c in this example up here, but it can be any valid variable name. And then in, this is some array that you want to iterate over. So count over the elements of. Yeah?
So the second argument always has to be an array.
Yeah. Well, okay. It has to be something that you can iterate over. So arrays are well, actually, arrays aren't the only thing. We can also do the same thing with strings. So for example, let's try that. Let's say s is equal to a long string. And now we can say, for each character c in s, print c. And so then we print the characters of that string one at a time. So really, you can, in your head, you can imagine turning this into a loop, which is saying, okay, look at the 0th element in this thing and now print it. Look at the 1th element in this thing and now print it. And the 2th element in this thing and print it. So it's really just iterating over s at 0, s at 1, s at 2, s at 3, and so on.
And each time that automatically
Well, it doesn't increase the value of c, it moves to the next element in the array. Yeah. So, think of the array as a lineup of students who are waiting outside my door, and I'm the counter. You come into my office, and I don't know, mark your exam or something, and then I kick you out and say, next student. Mark your exam, kick you out, and say, next student, and so on. Yep. Oh, the 3 dots, that's just because I'm working at the interpreter. And this is telling me that I could still put some more commands here, and they would be part of this for loop. So you don't see those don't come into play when you're programming, you're writing programs in files. But at the interpreter, I could still put in another command here, and it would be part of the for loop and get executed for every value of c. I'm only interested in printing c, so I just hit enter there and say that's the end of this for loop. It's because Python uses indenting to do block spacing, but when you're working at the interpreter, that's not always obvious how that works. It's much more clear in a file like this. So it's basically saying, here I could do something else, print x. And now if we do that, so one of you was asking about this. Let's see if it works. No, it doesn't work for me. So what happens if I count to 10 now? Yeah, so it's going to print 1, then an x, then 2, then an x, then 3, then an x, then 4, then an x. And what's it going to end with? An x. So actually there you kind of see why join is a handy function, because even here, if I tried to turn this into something for joining an array, I'd be stuck with an extra x at the end that I didn't want. So join handles that. I mean, it's not hard to write your own function that does that, but it's something that's a common annoyance that happens. Okay, so basically a for loop says for this variable, it should go and take on all the values in this array. In this case, the values are 1, 2, 3, 4, up to n. And for each of those values, it executes this block of code that comes after the loop. This is incredibly important. You'll use these all the time. So this is not the for loops that you see in Java, where you usually have a counter and you keep going until the counter is smaller than something, there's, you know, until the counter, while the counter is smaller than something, and then you keep incrementing the counter. This just goes through the elements of an array. And of course, the range function helps with this, because if you really wanted a counter, then what you do is you run a for loop over a range, like we're doing here. Okay, okay, this is really important. I'm willing to stop and answer questions about this now. Okay, good. All right. Here's something we can try. Let's write a function that zeros an array. It sets all the values in an array to 0. Okay. So, takes an argument A and sets all its values to 0. So how would we do that? So if we're not sure what to do, we could just pretend that we know the length of A and see what the code for that would look like. So let's say we know that A has 3 values. How would you set all its values to 0? Yep. Yeah, so I would really like to write code that looks like this. Problem is, I don't know the length of A somehow, and length of A could be 100,000, and I don't want to write 100,000 lines of code. So I want a loop to do this for me, but I sort of know now what the loop should be iterating over, right? It should be iterating over the length, these indices of A. So how do I loop over the indices of A? Yep, with a for loop. So let's try and do that. So I like to call my indices I, and is it for I in what? For I in A? Yep. That's meaningless. It doesn't mean anything. It's just to help us see what it is that I'm trying to do here. That's not Python code. Okay, so for I in A, what do we do? Yep. Let's try that. For I in A, I equals 0. So I want to say A equals A, B, C. And then say 0A. That didn't change A. Why is that? Well, I is a variable. I takes on the value A, and then we set I to 0. And then I takes on the value B, and then we set I to 0. I takes on the value C, and then we set I to 0. That doesn't really do anything to A, right? It's basically, this is like saying I equals A at 0. What's I? Oh, sorry. I equals A at 0. What's I? What's the string A? Now I change my mind and say I equals 0, but of course that doesn't affect this array. It just changes the value of I. If I want to change the value in the array, I need to say A at 0 equals something, right? So this I here, I don't want it iterating over the values that are in A. I want it iterating over the indices in A. because I want to do something like this. A at I equals 0. That's going to change A at position I. Problem is, the values in A are not 0, 1, 2, 3, 4, 5. They're, in this case, they're strings A, B, and C, so that won't work. So how do I get, what I want here is, you know, an array containing 0, 1, 2, 3, up to the length of A minus 1. How do I get that? Yep.
Range, I think it's range is 1 to, it's range of 0 to the length of A.
Well, the default range behavior is actually perfect for this.
Oh, really?
Yeah. Just iterate through this range, which is the first argument is the length of A. And so remember that one argument version of range starts counting at 0 and goes up to its argument minus 1. And so this is the perfect thing for doing this. So now I goes and takes on the values 0, 1, 2, 3, 4, 5, right up to the length of the array minus 1, and then it sets A at I equal to 0. Let's see if that works. Indeed. So this modifies the contents of A. Yep. So why I have to use a range? Well, because I want I to take on these values 0, 1, 2, 3, 4, all the way up to the length of A minus 1. And for loops in Python work by having a variable that iterates over an array. So I need an array that contains 0, 1, 2, 3, 4, 5, up to the length of A minus 1. And that's exactly what range gives me. If I give it an array of strings? Yep. In A? That won't work. So, question is, what happens if we do something like this? If we say for I in A at I equals 0. So let's trace through that as a mental exercise. So if I say for I in A, for this array A here, what's the first value of I that shows up? Nope. What's the first value I will take on? It'll take on the string X. So now I'm saying, I'm trying to do something like say A at X equals 0, and that doesn't work. Arrays want indices as their indexes, and indeed it gives you a pretty informative message. It says list indices must be integers, not strings. Okay. And indeed, if we try and run the code, 0, not so good, A, we get exactly the same error. It tells us on line 16 we said A at I equals 0, and it tells us that there's this index error. And that should clue us in that there's something wrong with the value of I here. It's a string, and it shouldn't be. Okay. Okay. A couple of other things you can do with arrays that are nice. You can add arrays together. Now, did John show you what happens when you add strings together? No? Okay. What's that? No. So what do you think A plus B is? ABC XYZ. And that doesn't change A and it doesn't change B. It's really a new array that has ABC XYZ in it. So strings, you can do the same thing. If you add two strings together, you get back another string, which is the concatenation of those things. Yeah?
I've heard that like adding strings together using the addition operator isn't as fast as joining up, like without joining.
As going through what?
As doing the dot join. Like I've heard it's not as fast.
Yes. If you're going to put a whole bunch of strings together and it follows the join pattern, or if you just want to put a whole bunch of strings together, then you should use an empty string dot join and then an array of those strings. Okay. So, for example, here is C. It's an array that contains the strings A, B, C, X, Y, Z. And let's say what I wanted to do was turn all that thing, flatten it out into one string. So I would not want to do something like C at 0 plus C at 1 plus C at 2 plus C at 3 plus C at 4 plus C at 5. Well, one reason is that's just a lot of code to write. The other is it'll actually be slow. Even if you used a for loop, it would end up being slow. What you'd really want, the faster way to do it is to say, I want to join C. C is a list of strings. Join takes a list of strings and puts them together with whatever separator you specify. And if I specify no separator at all, so just this empty string as the separator, then I just get the string that glues everything together. That's the best way to take a whole bunch of strings and glue them together if you have them in an array like this. Okay. So we can add arrays. B, A, and B. So we can add them. Arrays also support multiplication. What do you think happens if we multiply two arrays? Yeah. That would be nice, but actually what you get is an error. If you multiply two arrays, you get an error. But what you can do is multiply an array and an integer. In which case, you get the array added to itself that many times. So A times 3 is like A plus A plus A. That kind of makes sense, right? If A was just a number and you said A times 3, that's like A plus A plus A. Indeed, you get the same thing there. So you can take an array and multiply it by an integer. You can do the same thing with a string. Say S times 40, you get a long string. The string S repeated 40 times. So there's addition and multiplication. Here's something that's really nice. we'll probably continue this next class as well, but just to get you started, you can get one array from another array. So, for example, okay, so now we have this array A. It's got a bunch of things in it. It has a length. And sometimes you want to take this array A and derive from it some other array. And there's a nice notation for this. It's called list comprehensions. And it looks like this. Maybe what I would like to do is for each element in A, I'd like to have an array which gives me, so the A is a bunch of strings. Maybe I would like to have the lengths of those strings. So I would do something like the length of S for S in A. So this reads a lot like a for loop, right? We have this for S in A, so this says take the variable S and assign it each value in A, one at a time. And what do I want to do with S? Well, I want to know the length of that string. And then these square brackets around all this say, really, I want you to make this whole thing into an array. So what do you think comes out of this? What does the thing look like? It's an array. What do you think the first value is in the array? 4. The second value? Third value? Yeah. So you get an array in which each element is the length of the corresponding string in A. So you can turn one array into another this way. So for example, nice things you can do. We're computer scientists, so we should all know the powers of 2, right? Those are really important in computer science. So I could say something like, well, to help me remember that, show me 2 to the power x for x in starting at 0 and going up to, I don't know, 32. Then I get an array. So x takes on the values 0, 1, 2, 3, 4, 5, all the way up to 31. And for each of those values, I compute 2 to the power of x. So that gives me all the powers of 2. 1, 2, 4, 8, 16, all the way up to roughly 2 billion here, 2 to the power 31. So this is called what they call list comprehensions, and it's a very powerful way for turning one list into another related list. So to get values from these things. All right. So far, so good. Let's do one. Let's try and do something really fancy to finish with. A equals open. So I just opened a file on my computer. I happen to have a file called user shared dict words. It's used by things like text editors for spell checking. It's a fairly long list of words in the English language, 99,171 to be exact. I read that thing and then I split it up into lines. Okay? And so I can look at the words in there. A at 0 is A at 1 is A apostrophe S, A at 2 is this, A at 3 is abs, and A at 5,756 is Geronimo. It's a big list. There it is in its entirety. Some of those words I didn't quite like. So some of those words had apostrophes in them. Maybe I don't want those words. So now I'll say B is equal to all the strings in A, so S for S in A. And these list comprehensions allow you to place conditions on the things that you include. But only if S doesn't contain an apostrophe. Let's say S dot find equals -1. So a lot of words in A contained apostrophes, about 26,000 of them. So now we're left with 72,000 words, none of which have apostrophes. So if we look at B at 0, now we're getting, and B at 1, we're getting to some real words. And we can do all kinds of neat stuff with this now. For example, what if I want to find all the strings that start with zoo? I didn't mean to reset B there. So all the strings that start with zoo, there they are. Some surprising ones, maybe, maybe not. Here's another interesting one. Let's find all the palindromes. So a string is a palindrome if it's equal to its reverse. Right? That's what it means to be a palindrome, that the string S is equal to the string S when I reverse it. There's a list of all the palindromes in there. So that's probably a good place to leave it. We'll see a few more of these word tricks and other things we can do very easily this way in Python.